So we're reading this systems of equations. So the Smith family, the Harper family, they go to a book fair, cost them two different amounts, there's two different people. Here's what we do. To determine the cost of an adult ticket, you simply make it be X. And you make the cost of a child ticket be Y. That's simple. This is very easy to start. So you simply go, all right, 3X. Remember there was 3 adults right here? There was 3 adults and 1 child in the first family, and you paid $11. You see it? 3X plus 1Y equals 11. It's easy. You understand?
Yes.
Someone nod at me. Okay, thank you. And then it says I had 2 adults and 3 kids. So you go, okay, 2X and 3Y. But that costs $12. You see it? Okay. Now, every time you're looking for a solution, ladies and gentlemen, you are looking for a values of the letters. I just told this to my 8th graders. I said, solving, okay, is when you find the values of the letters that you can plug in to make it true. Right? When you solve this, hold on, x plus 8 equals 10. What's the answer? Why is it 2? Because 2 plus x is going to be a 2. That's the solution because 2 plus 8 is 10. You're looking for something that goes in here that makes this equal to 10. You understand? Malachi. Get it? So a solution, I like eye contact. I like eye contact. Thank you. So a solution here is an x and a y value that'll make that 11. Want to guess one? What would it be? Oh, 3 and 2. Would 3 and 2 work down here?
Yeah. 6. Oh, wait.
She's saying x is 3.
Yeah.
And y equals 2. Does that work down here?
Yep.
Okay.
6.
You just found it. That was pretty cool.
Can you explain that again?
But that would make it 3 adults, right?
No. X is the price of the ticket. So we're saying adult tickets cost $3 and child ticket costs $2. But the deal is when you find a solution is you have to find an x and a y value that work in both equations. The same x and the same y that work in both equations. That's the goal. She happens to find 3 and 2. It's not too hard. Okay? Now, how can we do that without just guessing and checking and looking and knowing? Just like Danielle's going, how would I get that? Okay, so let me show you how you can do this with technology. I without technology, but with graphing it. So can you rearrange this, please? What would that be? Quickly.
Y equals negative 3x plus 11.
Write it down on your paper right now. Everybody pick it up. Pick up your pencil. Write y equals negative 3x plus 11. Can you graph that?
Yeah.
How?
Put it in your whiteboard.
No, without a computer, without a graph calculator.
Oh.
What would you do? Go.
Start at 11.
Start at 11 and then
Down 3 over 1.
and we could draw a line. Works pretty good. Okay, next. Let's rearrange this equation. Y'all with me so far? Am I going too fast? Okay? Okay, that's the first one. We just did the first equation. Let's do this one. Let's rearrange this so I can get it to y equals so I can graph it. We've been doing this a lot lately, right, Victor? Okay, let's rearrange. Victor, if you were going to rearrange this, what would you do?
I think, would you like put the y on the outside?
On the right-hand side of the equal sign? Is that what you mean?
Yeah.
So you want to put the 3y over here on that side of the equals?
Yeah.
Okay, you got to make it a minus then, right?
Yeah.
Okay, and then leave the 2x over here. What do I do with the 12?
Subtract.
Put it on the left? Sure, this is one way to do it. There's many ways to rearrange, which is what Victor chose to do. It's fine. Anytime you move something onto the other side of the equal sign, you have to change the sign, right? And then what's the next step? Divide by negative 3. Okay, so I have y equals negative 2/3 x plus 4. How do you graph that on my graphing, on my line? Somebody else. Go to 4. Start at 4. And then down to over 3. Good enough. Draw your line. Sariana had the answer. She said the answer was x equals 2 and y equals 3. Is that what you said?
I didn't say anything.
You didn't?
No.
Who said 2 and 3? I'm giving credit where credit was owed to Ashley.
No. I thought it was Abby.
What guy
It
said
was
it?
me. Oh,
No, it
did?
wasn't.
Is that what?
Yeah.
Who said it?
Abby.
I thought
Abby
it was
said
Abby.
it?
So, I don't think.
Someone was brilliant and said 2 and 3.
I mean, I'll take
Someone
credit.
Okay, Malachi. We'll give Malachi all the credit.
I thought it was Noah.
Are you sure?
Malachi has the
Be honest,
credit.
boys.
I don't know who it was.
Okay.
Now, she said that long before we did any graphing. And we decided it actually worked. How did she get that? Well, check out your graph. Where do you see the point 2, 3?
Oh,
Where is it?
Yeah, I did say that.
Really
Okay.
intersect.
Yeah.
Where they intersect. Do you understand? We're looking for an x and a y value that work on both lines. In other words, I need an x and y value that both lines go through. Because when a line goes through the point, you can plug the point in, remember?
Oh, I get it, dude.
Yes. So all we have to do to solve the system, to find the answer, the x and the y that work for both, is find the point, the coordinates of the point that are on both lines. Done deal. It's brilliant. Noah. Oh, correct.
That's a new one.
Righty. It's the other way around. I couldn't remember what she said. Thank you, Noah. 3-2. 3-2. Go from here. 1, 2, 3, up 2. Sorry. Delete. There's not some coordinates. Let's change it. Yes?
So wait, if the point doesn't go through both, can you still plug it in?
You can plug it into one line. So like this point right here, it's a solution to the pink line. But it isn't a solution to the black line. It's not on the black line. So if you're trying to solve what we call a system, I better change it. If you're trying to solve a system, you need the x and the y value that work for both. You know what I'm saying? They got to work for both at the same time. Okay, let's go do another question. The coordinates of the point, let's find out the coordinates. Okay, the coordinates, okay. The intersection, write this down, the intersection is the solution. The intersection point, it's a point with coordinates, okay? Can you understand this like x and y? It's the solution. So where the two lines intersect. Can I say that one more time? You tell me, what's the solution? The intersection point. It's that easy. Okay, turn the page. Go all the way to class example number 1. The system of equations has been represented on the grid. They have done the graphing for you. They rearranged it, they put in their calculator, they put the picture up there. It says, go state the solution. What are you looking for? Tell me again, Ben, what is the solution when you see a picture like that?
The intersection.
The intersection point. What's the solution, Victor? And what is the intersection point here? Can we tell? Looks like it's 2, -1. Would you agree?
Yes.
Write it as an ordered pair. 2, -1. Good. Next. What's the solution, Miles? How do you find the solution graphically?
To what problem?
Any problem. If I graph 2 straight lines, how do I know where the solution is?
Make it y equals whatever and then graph the equation.
And then how do I know what the answer is?
We find the point of intersection.
The point of intersection. The point of intersection is the solution. Get it? Okay, I'm going to ask you again here in a minute. So we're going to graph this without technology, no problem. All we have to do is get them to what form? Y-intercept form. Get them to y equals. Okay, good. Let's do this question. Here's what I would do on this first one. I would leave the y right where it was. I wouldn't move the y. It's already positive. I would kick the 2x over and go +2. Sydney, are you okay with that?
Yeah.
Okay, do you see how the 2x changed to the opposite side? And it changed, but the y didn't. The y stayed. The 2 also stayed on the right-hand side, so it doesn't change either. The only thing that changes is the thing that moved. Understand? Okay, graph it. How do we do that? Abby Genesis, how do I do it? How do I graph that line?
You go to 2.
No, Abby Genesis, how do I graph that line?
Go up to 2
On the where?
on the Y.
Okay,
And then,
is there a point there?
yeah.
And then
And then you go down to
down 2/1. Okay. Should I give one more block? So good. Okay, there's that line. I graphed the line. You have to get good at getting into y equals. Aren't you glad we learned last chapter? Because this is going to be a breeze, right? Okay, how do I rearrange this line? Whoa, that's fun.
Take away the line.
Okay, now,
Leave the line.
leave the y.
Yeah.
Do whatever you want to do, actually.
Pick up the line.
Kick the y over. Okay, if, I'm going to put an equal sign down. If you kick the y over here on this side, what does it become?
Positive.
Okay, what are you going to do with the x? Leave it? What are you going to do with the 15?
Take away.
Kick it. If you kick it to the left side, it changes sign. Correct? We're getting pretty good at this?
Yes, ma'am.
Okay, now what? One last step. Divide by 3. So I have y equals, it's okay to write y on the right. It's okay. Okay, I get a negative 5 here. X over 3. I don't like it like that. Can I go 1/3 x? I like to put the 1 on it. Just makes it look better with the 1 on the top. Okay, how do I graph that? Okay, Danielle.
You got a 5
Where?
on the Y.
5?
Yeah.
Up here?
Negative.
Thank you. Negative 5. Do you have your signs wrong?
No, because I thought if you have negative 15 divided by negative 3.
Oh, who said it was a negative 3?
Well, I did it the other way. And
Okay, if you do it the other way, you leave your 3y here. Your 15 has to stay there. It's not a negative, babe.
It isn't?
And what I'm doing it her way.
Oh.
She's keeping the y on the left. The 15 is staying. The x is moving.
Oh.
And now you divide by a negative 3.
There you go.
So y is equal. I'm going to put this on the other. I'm going to put it here.
Messed this up.
You understand? It turns into the same thing.
Yeah, I got it right.
Okay. So I go to negative 5, and then I do what, Daniel?
Up 1 over 3.
Hey, look at that. I already have an answer? Where's my answer, Joey? Do you have is there an answer on it? What is the answer to a system when you graph it, Kale? The intersection point. Do I have an intersection point where 2 lines cross?
Yes.
Yes. What is the answer?
3 negative 4.
3. 3 negative 4. Put it in parentheses. That is the intersection point. Every point has an x and a y value, be sure. Okay, now here's where most kids don't like this part. It says verify it, check it. To check it, let me tell you this, and you say it very clearly and don't mess up. This is worth points. To check, you must put your answer, your solution, your x and your y, your coordinates. Get it?
Yeah.
Take your coordinates, you have to put them back into both equations and see if they work.
And then work it
Because if a line goes through the point, plug it in. Okay, so we have to make sure that those lines go through that point algebraically. So here's what this looks like. Ready? Don't cheat it. We're going to copy down 2. I'm going to put an x. I'm doing this one right here. I'm going to put an x. Quickly. -4 equals 2. Don't cheat this. Do it. It takes literally 10 seconds and it's an easy point. Right? 2 equals 2. I put the x and the y value where the x's and the y's are in the original equation.
Can you just pick whichever one they need to? They have to use.
I gotta do it into both. That is only 1. That's half a point. Half a point. You must put 2 equals 2. You must.
Yeah.
Yes, okay. Over here, I'm gonna use this equation now, and everywhere I see an x, the x is coming out, Kale, and the y is going in. Understand? The x comes out, the y goes in. Get it, Cece? Joey, why are you talking?
Wait, Mr. Sloan.
What? Ask, it's good.
On the whole thing, I don't know.
Okay,
Just see.
I find a point where they intersect. I need to take this point This is an X and this is a Y value, and I need to make sure that they actually work. I think that this line goes through this point, and I think this line goes through the same point. But if this line goes through this point, I should be able to take the point and plug it into the X and Y, and it should work.
Okay, where'd you get the 3 though?
Here?
Oh, I see.
So I'm using this one here. I'm taking the X and replacing the X with a 3, and replacing the Y with a -4. Y'all on it?
Yeah.
Okay, good.
I'm sorry.
3 plus 12, is that true? Does this work? Yes, 15 does equal 15. I will accept no less. I won't accept anything else. I won't accept 12 plus 3 equals 15. That's not, I don't care. I want to see 15 equals 15. That's how you be a good mathematician. You prove one side is exactly the same as the other. Go all the way to 15 equals 15. Yes, ma'am? You are a mathematician.
Let's go.
Okay. Using your graphing calculator, I just want to, you already know how to do this. I'm going to skip this. Turn it into y equals. Do you know how to find the calculate the intersection? Second function calculates number 5 on the intersection. Done deal. Okay, good.
Yes, and that's what this is.
The only thing you have to make sure you can find is a good window. Okay? Look for a good window. You hate finding a window? Okay, let's just do class example 4. So flip the page. Let's just do the class example before we go. Okay, because this one doesn't have an X and Y. It has A's and B's. I don't care. What do you, just change them. What does A want to be? Okay, X, and make the B be a Y. Okay, you just have to be consistent. Okay, just change them to X's and Y's. Okay, now let's go. I can rearrange my equation perfectly, people. Let's rearrange the first equation. I'm going to rewrite it so it looks better. 6x plus 7y equals 5. Okay, turn it into y equals. What are you going to do?
Divide by.
First, get the y alone. So are you going to keep the y here?
That's what I'm saying. Divide
Keep-
by 7.
Keep the y here though. Move the 6x over. If you're keeping something on the same side, don't change its signs. And then divide by 7, Ben. So y is going to equal -6/7 x plus 5/7. I'm going to put that on a graphing calculator in just a second. My other equation, although it looks kind of messy there, is like this. I'm trying to solve for y. Yes, ma'am. Okay. So y equals 3 over 14x. Okay, let's go get our calculation and let's go see if we can do it. Okay. Get your y calculators out. Go into y equals. Start typing those in there. 1 in y1, 1 in y2. You need to put both of them. What is up? You have to put them both in there together. And 1 is in y1 and 1 is in y2. When I say together, I don't mean together. Okay.
You need to do an account to use that calculator.
Yes.
I have a question.
Yes. Go ahead and do it and get me an answer.
Wait, the X in the Y equals, like for the second one, it was Y equals 3 over 14x. We put the X in the Y equals.
Y equals 3 over 14x. You know what they're going to make us do now? Enter you have to enter a password and then the code that comes on your phone. I have to call a double verification for our stinking Chromebooks. So every time I lock it, I have to to open my Chromebook.
I know, but imagine.
I have to carry my phone around. Every time I open my Chrome, I'm going to have to type in a stinking number from my phone.
What if you lose your phone and you can't teach your class?
Okay, I don't carry my phone when it's in the drawer so it can ring over there. Okay. All right. Stupid. Okay. Do you have an intersection point already?
Yeah.
You do?
Yeah, but I don't think it's right.
Oh,
Yeah, mine's really funky.
that's okay.
I'll show you what mine is.
Compare. Talk to each other.
I got that.
Did you get that?
Okay, wait, I have to know this.
No, I believe in the exact same thing that she did. Really. Second tray.
Wait, guys, I got
That's mine.
Guys, I got the same.
I got mine.
She did that.
Okay, Kale and Malachi. I don't mean Kale, sorry.
She got the same.
I meant Malachi and Jeffrey and Joey.
Yeah, you got the same.
Okay, now here's we go. I get a funky point. It looks like 0.66667 and 0.1428. The question says exact values. Here's what you're gonna do. Watch this. Does anybody know what 0.66 repeating is?
Oh, is it like a line over top of the line?
Yeah, what is that in terms of a fraction? 2/3.
Yeah.
Now, what is 1/3? 0.3333. So 0.6 is two of those, right? But let's pretend you don't have a clue on earth. Go like this, hit quit, go to quit, go to your blank screen, hit X button, go X, math, frac, 2/3. Now you want to know what that, go to your quit your screen, go to the blank screen, go X, math, frac. Okay, now you want to know your Y button. Y looked a little funky. You have to have your solution intersection point on your graph or it won't work. Now the Y button, is everybody ready for Y?
Yeah.
Okay, Danielle and Paige, if you missed the X, let's get the Y. Okay, there's a Y on the number 1 button. Do you see it? But it's a funny color. You'll have to hit alpha 1. Alpha 1 gives you the Y. And then we hit math, then we hit frac, and that 0.1412 whatever becomes 1/7. Brilliant. Did you get it? Kylie? Danielle?
My settings are off.
Okay. Shh. Shh. Does your graph look like this?
Yeah.
Did you calculate an intersection?
Yeah.
What was your intersection point? You didn't get 0.666 and 0.14?
Oh, yeah, I did.
Okay.
And then,
Quit the screen. Second function, quit.
okay.
Then go X, math, frac.
Oh, okay. So,
Okay, I'm done. You have homework to do. Begin. I didn't verify it algebraically. We could. I'm not going to do it. Put the point back in. Okay, you have half an hour. It is the last lesson. It's called Systems. Chapter 10. Yes, chapter 10.